Hello good people, I'm going to talk about addition and subtraction of fractions. I'm going to mark 1/6 on this line. Now suppose that I want to add another 3/6. On the line that would look something like this. 1, 2, 3. By inspection alone I can see that the result is 4/6. How do I show that using fractional notation? When it comes to addition and subtraction of fractions, the denominator, the number beneath the division line, has to be the same. And if that is the case, all I need to do is either add or subtract the numerators, the numbers above the line. In this case, we are dealing with addition. So I will have 1 plus 3 above the line, and the denominator remains unchanged. Please note, I did not have 6 plus 6 beneath the line. 1 plus 3 is 4, and so I can say that 1/6 plus 3/6 equals 4/6. What happens if I want to add or subtract fractions that do not have the same denominator? Let's say I have a quarter, and I want to add 4/6 to that quarter. I cannot simply add 1 and 4. The denominators are not the same. What does this look like visually on my line? I already have the quarter marked in, so let me copy-paste the 4/6. By inspection, my answer is somewhere between 3 and 4 quarters. But that is not precise. And in order to do it precisely, I need to make sure that my two fractions have the same denominator. To find the lowest common denominator for these two fractions, or any two fractions for that matter, I need to ask myself what is the lowest value that is divisible by both of these numbers. Another way to approach this is to ask yourself what is the lowest value where 4 and 6 are factors. The answer in this case is 12. And now I need to convert 1/4 into 12ths. How many times do I need to multiply 4 to get to 12? Well, the answer is 3. Which means that I need to multiply my 1/4 by 3/3. What about the 4/6? In order to get to 12ths, I need to multiply 6 by 2, which means this entire fraction will be multiplied by 2/2. And now I can say 1 multiplied by 3 is 3, 4 multiplied by 3 is 12. 4 multiplied by 2 is 8, and 6 multiplied by 2 is 12. The denominators are now the same, and I can add the numerators. 3 plus 8 is 11, so the answer is 11/12. Let's confirm this visually. Here is the same line length divided into 12ths. I'm going to mark in a quarter and then 4/6. By inspection, I can see that everything checks out. What if your knowledge of the multiplication table is a little bit rusty? The truth is, we do not necessarily need to know what the lowest common denominator is or what value has both 4 and 6 as a factor. So let me write 1/4 plus 4/6 again. This time I'm going to find a common factor. It's not necessarily going to be the lowest common factor. I'm going to start by taking the first fraction and multiplying it by the denominator of the second fraction. To that, I'm going to add the second fraction that is being multiplied by the denominator of the first fraction. 1 multiplied by 6 is 6, 4 multiplied by 6 is 24. 4 multiplied by 4 is 16, 6 multiplied by 4 is 24. The denominators are the same, I can add the numerators. 6 plus 16 is 22, and the denominator remains 24. At this stage you might say, hold on, you demented paperclip, we did not end up with the same result. Up above in yellow we have 11/12ths, down below in purple we have 22/24ths. Keep in mind, we can express the same value using different fractions. 11/12ths and 22/24ths are equivalent. If I simplify 22/24 by dividing both numbers by 2, I will once again end up with 11/12ths. Everything checks out. In summary, When it comes to addition and subtraction of fractions, we add the numerators only, but we can only do that if the denominator is the same. That is all for now, and I will see you on the flip side.